today we're going to be talking about the comparison test, which we've already discussed, and the limit comparison test. So the direct comparison test is when you have a small series and a big series. So if we have a small series A and a big series B, there are two conclusions that can be made. If the big series comes to a limit, which means it converges, then the smaller series also has to. If the smaller series diverges, then the bigger one also has to diverge. So you have to choose a candidate to compare to. So you want to choose something similar to what you have, but something that we know about. So I'm going to compare this to 1/4 to the k. Okay, and you can put in all the stuff, but why did I pick this one? Well, this is an infinite geometric series with a ratio of 1/4, which means this series converges. Then we're going to build the comparison between these two. So I have 4 to the k plus 1 will be bigger than 4 to the k. So if I take the reciprocal, that will be smaller, which means the series 1/4 to the k plus 1 is less than 1/4 to the k. We know this one converges, which means this one converges. Okay, these next two you'll notice are pretty similar. I'm going to compare to 1/the k, which is really 1/k to the 1/2, which means I can use the PSeries test, where p equals 1/2, which is less than 1, which means this series diverges. Now let's build the comparison. We have the square root of k minus 1 will be less than the square root of k, which means 1/the square root of k minus 1 will be bigger than 1/root k, which means the series will be bigger. Well, we said that the smaller one diverges, meaning the bigger one diverges. Well, let's look at this one. I'm still going to compare to 1/root k, which is a p-series, p equals 1/2, which diverges. The issue is going to be when we build the comparison. I've got the square root of k plus 5 will be bigger than the square root of k, which means 1/root k plus 5 will be less than 1/root k. And if I can show that the bigger series diverges, that doesn't tell me anything. That's inconclusive. Because if the bigger series diverges, fine. The other one could diverge or it could converge. We will revisit this one later with the limit comparison test. Okay, this is going to be similar. I've got two series that look very, very close. I'm going to compare this one 1/4k squared, which is a p-series, with p equals 2, which is greater than 1, which makes this series converge. When I build the comparison, 4k squared plus 2k will be bigger than 4k squared. So 1/4k squared plus 2k is less than 1 over 4k squared. Okay, so we know that the bigger series converges, which means the small series converges. Okay, looking at this one, I'm still going to compare it to this one, which still converges, and I'm not going to go through all the reasoning again. But when I build this one, 4k squared minus 2k is going to be less than 4k, which means that's going to be bigger than that. If the smaller series converges, we're inconclusive. Just like the other one, if the small series converges, that doesn't tell us anything about the bigger series. So that's inconclusive, but again, we will revisit this with the limit comparison. All right, so we have a very interesting series here. I'm going to compare this the series. I'm going to leave the k to the negative 1/2 over 2 plus, I'm going to replace the sine squared with a 1, because sine is always between negative 1 and 1, so sine squared is always going to be between 0 and 1. Why did we pick this series? Well, this is now going to be 1 over 3 k to the 1/2, which is a p-series. P is equal to 1/2, which is less than 1, which means this diverges. Okay, so let's build this comparison. I'm going to start with just the sine squared k. That will be less than or equal to 1. So 2 plus sine squared k is going to be less than or equal to 3. Okay, then I'll multiply by k to the 1/2. So 1 over k to the 1/2, 2 plus sine squared k, is going to be bigger than or equal to 1 over 3k to the 1/2. So the series, and I'll go ahead and put it up so it looks like that, k to the negative 1/2 over 2 plus sine squared k is greater than the series k to the negative 1/2 over 3. We said this one diverges and is smaller, so this one diverges. Okay, I'm going to do a similar thing here. I'm going to compare to just 1 over k squared. P series, P equals 2, which is greater than 1, so this series converges. And cosine 1 over k. Okay, cosine is always between negative 1 and 1, so whatever this is, no matter what k is, that's going to be less than or equal to 1. So cosine of 1 over k squared is going to be less than or equal to 1 over k squared. So we determined that the bigger series converges, which means the smaller series converges. So I'm doing a comparison test with 1 over natural log k squared. We are conveniently told to use that the natural log is less than 2 root x. So let's just start there and go with it. Okay, so natural log is less than 2 root x. We're building this series, so I'm going to square both sides. So I squared 2 root x, we get 4x. So then the reciprocal, actually we should make these k's. Is going to be bigger than 1 over 4k. So this series, okay, so this is the comparison, but what conclusion can we make? This series is harmonic. And we know harmonic series diverge. It is smaller, so we can make a conclusion that this one also diverges. Okay, I'm going to compare this one to 1 over, actually it's 2 over k factorial. Okay, because we know that cosine is going to just equal a number between 0 and 1. But does this one converge or diverge? You probably have an idea, but let's go ahead and run the ratio test. So limit as k goes to infinity of 2 over k plus 1 factorial over 2 over k factorial. Times k factorial over 2, and as always, stuff goes away. So we're just left with the limit as k goes to infinity of 1 over k plus 1, which is 0, which is less than 1, which means this series converges. Build the comparison. 2 cosine squared is going to be less than 2 because cosine squared is between 0 and 1. So then 2 cosine squared k over k factorial will be less than 2 over k factorial. This series we showed was convergent. Leading us to the conclusion that this one is convergent. The limit comparison test works a little bit differently. You're still going to pick a second series to compare to, but rather than build a comparison, you're going to take the limit of the series. If the limit is a finite number, okay, if p is finite, then they both converge or both diverge. This is easier to use than the comparison test. In fact, like I said, we're going to revisit these two and we'll actually be able to make a conclusion with the limit comparison test. So I'm still going to compare this one to 1 over 4k squared, which is still a p series with p equaling 2, which is greater than 1. So this converges. Okay, and then here's how we do the limit comparison. We're going to take the limit, and it doesn't matter which one goes on the top or the bottom. I'm just going to put the original one on top. So this is going to be the limit as k goes to infinity of, when I multiply by the reciprocal, we're going to have 4k squared over 4k squared minus 2. That limit is going to just be 1, which is finite, which means they both converge. So that's how you do the limit comparison. We take the limit of two similar things. If it equals a finite value, then they both behave the same, whether they're convergent or divergent. So let's do the same thing here. Just like before, we're going to compare this to 1 over root k. So this is a p-series with p equaling 1/2, which is less than 1, so the series diverges. Now with the limit, we're going to take the limit as k goes to infinity of 1 over root k plus 5 over 1 over root 5. So that's going to be root 5 over root k over root k plus 5. Well, these have the same degree, so this is again going to be 1, which is finite, so they both diverge. In this next one, we're going to compare to 1 over 2 to the k, or 2k, which is harmonic. Therefore, it diverges. Okay, and we'll do the limit as k goes to infinity of 1 over 2k minus 1 over 1 over 2k. And again, we get 1, which is finite, so they both diverge. Okay, here, I'm going to compare to, I'm going to take off all the extra, I'm just going to look at the two big ones. I'm going to have 5k cubed over k to the 4th. Okay, well if I simplify that down, that's going to equal 5 over k. Well, that's harmonic. Therefore divergent. So we're going to have the limit as k goes to infinity of that whole big mess all over 5 over k. Okay, well when we copy.flip, the top is all going to get multiplied by k. So I'm going to have 5k to the 4th minus 4k cubed plus 3k. And then the denominator is going to get multiplied by 5. So we're going to have 5k to the 4th. Doesn't really matter past here, but I'll go ahead and do it. Okay, well, the limit, we've got the same degree. 5 over 5 is 1 again. So they both diverge. Okay, just a few more examples. I'm going to compare this one to 1 over the square root of k cubed. This is going to be a p-series with p equaling 3 over 2, which is bigger than 1. So this will converge. So we'll multiply by the reciprocal. So we'll have root k cubed over root k cubed minus 5k. So again, these are going to have the same degree, so we again get a limit of 1. So they both converge. All right, our final example here. I'm going to compare this to just the 5 over to the k over k factorial, because the k and the 3 are really going to have very little impact. So I'm going to do the ratio test. So we're going to have 5 to the k plus 1 over k plus 1 factorial over 5 to the k over k factorial. So 5 to the k, 5 to the 1 over k plus 1 times k factorial over k factorial over 5 to the k. Cross off, cross off, cross off, cross off. So we get the limit as k goes to infinity of 5 over k plus 1, which is 0. Okay? Less than 1 converges. And we've talked before about how factorials grow faster than exponentials. So we're going to do the limit as k goes to infinity of 5k plus k over k factorial plus 3 over 5k over k factorial. Okay, well really what's going to take over is the fact that we've got a factorial on the top, factorial on the bottom, 5k on the top, 5k on the bottom. These two will have very little impact. So this limit is going to be 1, which means they both converge. So the limit comparison test is a little bit more flexible than the direct comparison test, and can be used in place of it if you choose. Certain scenarios might be easier to use one than the other, but typically limit comparison will be easier.